In this video, you will become an expert at identifying the critical parts and how to graph a vertical hyperbola. So let's look at the diagram below. In this diagram, you'll notice that a hyperbola looks very similar to two parabolas, vertical having one opening up and one opening down. That means it also has two vertices. The vertices in a hyperbola also connect what we call the transverse axis. It is important to note that the transverse axis does not have to be the longest axis, and therefore a squared will not always be the largest the denominator. Next, similar to an ellipse, a hyperbola also has two covertices. These covertices connect what we call the conjugate axis. It is important to note that the conjugate axis does not have to be the smallest axis. That also means that b squared does not have to be the smallest denominator. Now, where these two axes intersect in the middle is still called our center. And the two dots inside the curve are still called our foci, or plural for focus. Again, I'd like to point out that these are still inside the curve, and for a hyperbola, that means it's going to be a greater distance away from the center than our vertices. Let's now define some of the critical information. Now, what's going to make this a hyperbola versus an ellipse or a circle is the fact that there's a subtraction sign in between the two terms. If you remember, for an ellipse and a circle, these were both addition. What's going to make it vertical is the fact that y is the term that is positive or first. Now your center is still going to be HK, just like it was with ellipses and circles. But please note, because y is the first term, the opposite of k is the y value, and the opposite of h, again, is the x value. Next, we have our vertices. They are still going to be a units away from the center, but again, a squared does not have to be the largest value anymore. And because it's underneath y, we want to take that value of a and add and subtract it to the y value, k, of the center. Now again, I would do this from the graph, and so I would move a units from the center the direction of the transverse axis. So here for vertical, up and down. For my co-vertices, this is still going to come from B, but now we want to go the opposite way. So we would want to go horizontally. And therefore, add and subtract B to the x value of my center, H. Now again, from the graph, This means I would move B units the opposite direction. Now, C is still going to be used to find the length from the center to each focus. And it's going to be the square root of A squared and B squared, but this time we're going to add them. If you remember, I said that A squared does not have to be the largest value. And so if it wasn't always the biggest and we subtracted these like we did in an ellipse, you might end up taking the square root of a negative number, which would not be a real solution. And of course we want a real solution here. So in a hyperbola, we're going to add A squared and B squared and then take the square root to get C. As far as what you do to get your foci, we're still vertical, so we still want to move up and down C units from our center. Now that we've defined everything, let's do a few examples below. First thing that I'm going to notice is that y is the first term and the positive term in both examples A and B, meaning that these have vertical transverse axes. Next, I would note that this isn't written the way that we have it defined above, so I would probably rewrite it. Remember, you can always put something over 1 to make it a fraction. Next, let's look at my center. Because there's nothing error subtracted to x or y, my center is going to be 0, 0. Again, remember that the x value of the center came from this value, the second term, and this, the y value of the center, came from the first one, since y was first. Then I would, of course, go ahead and graph that. For my vertices, remember, it is going to be A units from the center, but A, again, always has to be from the first denominator. It doesn't matter if it's bigger or smaller, it's always first. And so since we're vertical, I want to move 8 units up and down from my center. If we name those, we're at 0, negative 8, and 0, positive 8. Next, for my co-vertices, this is going to still be B units away from the center, the opposite direction of the transverse axis. So that's going to be left and right, only 1 unit. If I name these, I'm at negative 1, 0 and positive 1, 0. Just like with an ellipse, at this point I would go ahead and do my graph before you have the foci plotted, so that you don't accidentally draw a hyperbola through it. Now, graphing of these is going to be a little different. We have to make a box that connects the vertices and the co-vertices. So you'll notice I'm drawing a dashed outline of a box along the perpendicular and horizontal parts of the vertices and the co-vertices. From here, I want to draw these asymptotes through the corners of the box and the center. These asymptotes are going to tell me how wide or how skinny to draw my hyperbolas. Next, because this is a vertical hyperbola, I would go up to the vertical up and down vertices and draw in my hyperbola. Once I have that drawn, this is when I would go ahead and look at C, figure out my foci. Again, remember it's going to be A squared plus B squared. And so I'm taking the square root of 64 plus 1, and so that's square root of 65. Since I can't simplify square root of 65, I would go ahead and write that for C. Next, to be able to put these in my chart, I remember that I'm going vertically, and so I want to take 0 and add and subtract square root 65 to it, since 0 was the y value of my center. Of course, this could also be written 0, comma, plus or minus square root 65. And to plot them on my chart, I have to figure out the decimal approximation of square root 65, which is about an 8.1. So from my center, I want to go 8.1 up and down vertically, because again, the transverse axis is vertical. At this point, please pause the video and complete example B. Please now check your answers with mine. And again, notice 36 was the first one underneath y, and that's why it was vertical, and that's why I moved up and down 6 units from my center to get my vertices. Since 9 was second, making b a value of 3, I moved the other direction horizontally 3 units from my center. Now to get c, I again took the square root of a squared, 36, plus b squared, 9. And that gave me square root of 45. This time this radical does simplify. That's the same thing as square root 9 times square root 5. And the square root of 9 gives me 3 times the root 5. And so that's what I wrote, the simplified radical for c in my chart. Since I'm vertical, I wanted to add and subtract that value to the y value of my center. But since 0 plus or minus 3 root 5 is the same thing as plus or minus 3 root 5, I just wrote that. Now to graph the foci, I had to figure out the decimal approximation with my calculator, which was about 6.7. And again, because I'm vertical, I went up and down 6.7 units from the center. Again, notice the foci are inside the curve, and for a hyperbola, they are going to be further away from the center than our vertices. Please now talk to your partner about the similarities and differences and get their critical information, and then complete the examples on the next page.